Section 5.2 Dual Air Brake. Most heavy-duty vehicles use dual air brake systems for safety. A dual air brake system has two separate air brake systems which use a single set of brake controls. Each system has its own air tanks, hoses, lines, etc. One system typically operates the regular brakes on the rear axle or axles. The other system operates the regular brakes on the front axle and possibly one rear axle. Both systems supply air to the trailer if there is one. The first system is called the primary system. The other is called the secondary system. Before driving a vehicle with a dual air system, allow time for the air compressor to build up a minimum of 100 psi pressure in both the primary and secondary systems. Watch the primary and secondary air pressure gauges, or needles, if the system has two needles in one gauge. Pay attention to the lower air pressure warning light and buzzer. The warning light and buzzer should shut off when air pressure in both systems rises to a value set by the manufacturer. This value must be greater than 55 psi. The warning light and buzzer should come on before the air pressure drops below 55 psi in either system. If this happens while driving, you should stop right away and safely park the vehicle if one air system is very low on pressure. Either the front or rear brakes will not be operating fully. This means it will take you longer to stop. Bring the vehicle to a safe stop and have the air brake systems fixed. One-way check valve. This device allows air to flow in one direction only. All air tanks on air brake vehicles must have a check valve located between the air compressor and the first reservoir. The check valve keeps air from going out if the air compressor develops a leak. Inspecting air brake systems. You should use the basic 7-step inspection procedure described in Section 2 to inspect your vehicle. There is more to inspect on a vehicle with air brakes than one without them. These components are discussed below in the order that they fit into the 7-step method. During Step 2 engine compartment checks. Check the air compressor drive belt if the compressor is belt driven. If the air compressor is belt driven, check the condition and tightness of the belt. It should be in good condition. During Step 5 walk around inspection. Check slack adjusters on S-cam brakes. Park on level ground and chock the wheels to prevent the vehicle from moving. Release the parking brakes so you can move the slack adjusters. Use gloves and pull hard on each slack adjuster that you can reach. If a slack adjuster moves more than about 1 inch where the push rod attaches to it, it probably needs adjustment. Adjust it or have it adjusted. Vehicles with too much brake slack can be very hard to stop. Out of adjustment brakes are the most common problem found in roadside inspections. Be safe. Check the slack adjusters. All vehicles built since 1994 have automatic slack adjusters. Even though automatic slack adjusters adjust themselves during full brake applications, they must be checked. Automatic adjusters should not have to be manually adjusted except when performing maintenance on the brakes and during installation of the slack adjusters. In a vehicle equipped with automatic adjusters, when the push rod stroke exceeds the legal brake adjustment limit, it is an indication that a mechanical problem exists in the adjuster itself. A problem exists with the related foundation brake components, or the adjuster was improperly installed. The manual adjustment of an automatic adjuster to bring a brake push rod stroke within legal limits is generally masking a mechanical problem and is not fixing it. Further, routine adjustment of most automatic adjusters will likely result in premature wear of the adjuster itself. It is recommended that when brakes equipped with automatic adjusters are found to be out of adjustment, the driver takes the vehicle to a repair facility as soon as possible to have the problem corrected. The manual adjustment of automatic slack adjusters is dangerous because it may give the driver a false sense of security regarding the effectiveness of the braking system. The manual adjustment of an automatic adjuster should only be used as a temporary measure to correct the adjustment in an emergency situation. It is likely the brake will soon be back out of adjustment since the procedure usually does not fix the underlying adjustment problem. Note, automatic slack adjusters are made by different manufacturers and do not all operate the same. Therefore, the specific manufacturer's service manual should be consulted prior to troubleshooting a brake adjustment problem. Check brake drums or discs, linings, and hoses. Brake drums or discs must not have cracks longer than 1/2 the width of the friction area. Linings, friction material, must not be loose or soaked with oil or grease and must not be worn dangerously thin, less than 1/4 inch. Mechanical parts must be in place, not broken or missing. Check the air hoses connected to the brake chambers to make sure they are not cut or worn due to rubbing. Final air brake check. All air brake system tests in this section are considered important and each can be considered critical parts of the in-cab air brakes test. The items marked with an asterisk in this section are required for testing purposes during the vehicle inspection portion of the CDL skills test. They may be performed in any order as long as they are performed correctly and effectively. If these items are not demonstrated and the parameters for each test are not verbalized correctly, it is considered an automatic failure of the vehicle inspection portion of the skills test. Do the following checks instead of the hydraulic brake check shown in Section 2, Step 7. Check brake system. Applied leakage test, 1 minute hold. To perform this test, the driver must start with the engine running and with the air pressure built to governor cutout 120 to 140 psi or another level specified by the manufacturer. The driver identifies when cutout occurred, shuts off the engine, chocks the wheels if necessary, releases the parking brake, all vehicles, and tractor protection valve combination vehicle, and fully applies the foot brake. The driver then holds the foot brake for 1 minute after stabilization of the air gauge. The driver checks the air gauge to see that the air pressure drops no more than 3 pounds in 1 minute, single vehicle, or 4 pounds in 1 minute, combination vehicle, and listens for the air leaks. The driver must identify how much air the system lost and verbalize the maximum air loss rate allowed for the representative vehicle being tested. Note, for a Class A combination vehicle, if the power unit is equipped with air brakes and the trailer is equipped with electric surge brakes, the pressure drop should be no more than 3 psi. 3 psi for single vehicles, 4 psi for a combination of 2 vehicles, 6 psi for a combination of 3 or more vehicles. Important, the maximum air loss rate for a combination of 2 or more vehicles is 3 psi if the towed vehicles are not equipped with air brakes. An air loss greater than those listed above indicates a problem in the braking system and repairs are needed before operating the vehicle. If the air loss is too much, check for air leaks and fix any that are identified. Note, for testing purposes, you must be able to demonstrate this test and verbalize the allowable air loss for your vehicle. For testing purposes, identify if the air loss rate is too much. Low air warning device. To perform this test, the vehicle must have enough air pressure so the low pressure warning signal is off. The engine may be on or off. However, the key must be in the on or battery charged position. Next, the driver begins fanning off the air pressure by rapidly applying and releasing the foot brake. Low air warning devices, buzzer, light, and flag, must activate before air pressure drops below 55 psi or the level specified by the manufacturer. The driver must indicate the approximate pressure when the device gave warning and identify the parameter at which this must occur, no lower than 55 psi. For testing purposes, identify and verbalize the pressure at which the low air pressure warning signal activates and identify the parameters at which this should occur. On large buses, it is common for low pressure warning devices to signal at 80 to 85 psi. If testing in a large bus, Identify the parameters mentioned above, 55 to 75 psi, and inform the examiner that your vehicle's low pressure warning devices are designed to activate at a higher pressure. If the warning signal does not work, you could lose air pressure and not know it. This could cause sudden emergency braking in a single circuit air system. In dual systems, the stopping distance will be increased. Only limited braking can be done before the spring brakes come on. Note: farm labor vehicles and Type 1 school buses must be equipped with both an audible and visible type warning device. Spring brake test. To perform this test, the parking brake, all vehicles, and tractor protection valve combination vehicles must be released, engine running or not, as the driver fans off the air pressure, normally between 20 to 45 psi, or the level specified by the manufacturer on a tractor trailer combination vehicle. The tractor protection valve and parking brake valve should close pop out. On other combination vehicle types and single vehicle types, the parking brake valve should close or pop out. The driver must identify and verbalize the approximate pressure at which the brakes activated. Note: the parking brake valve will not pop out on buses that are equipped with an emergency park brake air reservoir tank. If your bus is equipped with an emergency park brake air tank, you must perform the spring brake test for triple reservoir vehicles to check the automatic actuation of the spring brakes. Spring brake test for triple reservoir vehicles. If the parking brake valve does not pop out when the air pressure has been reduced to approximately 20 psi, you must demonstrate that the spring brakes have activated. To do this, you must remove the wheel chocks if necessary, leave the parking brake valve in the open release position. With the engine running, put the vehicle in a forward gear and attempt to drive forward. The spring brakes should drag and prevent the vehicle from easily moving forward. If the spring brakes do not prevent the vehicle from easily moving forward, your road test will be postponed. Note: this test must only be performed on single vehicles designed with an isolated parking brake reservoir. Do not perform this test on combination vehicles. Check the rate of air pressure buildup. To perform this test, the engine must be running at normal operating idle, typically 600 to 900 RPMs. Observe the air gauge to determine if the pressure builds at the proper rate. For dual air systems, the pressure should build from approximately 85 to 100 psi within 45 seconds. For single air systems in pre-1975 vehicles, the pressure should build from approximately 50 to 90 psi within 3 minutes. For testing purposes, you must verbalize the parameters of the test and identify if the vehicle met the appropriate standards. Test air leakage rate. There are 3 tests as follows. Static leakage test. With a basically fully charged air system within the effective operating range for the compressor, turn off the engine, release all brakes, and let the system settle. Air gauge needle stops moving. Time for 1 minute. The air pressure should not drop more than 2 psi for single vehicles, 3 psi for a combination of 2 vehicles, 5 psi for a combination of 3 or more vehicles. Important: the maximum air loss rate for a combination of 2 or more vehicles is 2 psi if the towed vehicles are not equipped with air brakes. An air loss greater than those listed above indicate a problem in the braking system, and repairs are needed before operating the vehicle. Test parking brake. Fasten your seatbelt, set the parking brake, and gently pull against it in a low gear to test that the parking brake will hold. Test service brakes. Wait for normal air pressure, release the parking brake, move the vehicle forward slowly, about 5 miles per hour, and apply the brakes firmly using the brake pedal. Note any vehicle pulling to one side, unusual feel, or delayed stopping action. This test may show you problems which you otherwise would not know about until you needed the brakes on the road.